So there's no problem at all if there's a square root in the numerator. You just want to make sure that you have no square roots in the denominator. And then lastly on this one, remember you always pick the number that's inside the square root that's in the bottom. So I'll multiply this one by the square root of 5 over the square root of 5. This 2 is on the inside of its square root. So when I do the square root of 2 times the square root of 5, remember from 4.3 from yesterday's lesson, it's going to be the square root of 10 and the square root of 25. The 25 can come out as a 5. The 10 stuck on the inside, so that one's not going to change. And so you would get this as your final simplified answer. And remember, it's good because there's no square root in the denominator. So kind of just summarizing what we've done in these first 6 problems before we move on, if there is no square root left over in the denominator after you break it up and do the 2 square roots, then you're good and you don't have to worry about doing this extra thing. But this part in yellow, it's called rationalizing the denominator, and it means when you pick a number, 7, 6, and here 5, you pick a number to multiply the fraction by that gets rid of any square root that's left over in the denominator. So remember, you get to pick this number, and the number that you pick will always be what was underneath in the square root in the denominator, what was underneath the square root in the denominator, and what was underneath in this one, the square root in the denominator. So that's how you're picking which number you're working with. The notes today finish with these 3 last examples, and each of them is just a little bit different. So each one of them has just a small step that makes them a bit not the same. There are some things on these problems that you might be able to simplify before you start, but you can also simplify them afterwards. So you might be able to notice on these problems that 6 over 3, the 6 is under the square root and the 3 is under the square root. Now it is also true that the 3 is underneath its own square root in the denominator, but if I can be smart enough to recognize that right now these 2 are split up, but I could write them so that they're back together underneath the same square root, I could write this as 8 times the square root of 6 divided by 3. And then I can do 6 divided by 3, and so it's going to turn into 8 square root 2. And that would be my final answer. I could also go through all the steps of having to rationalize this denominator, but it's faster to recognize that just like up here on letters A, B, and C, when they're together under the square root, I can break them up and think about them separately. But when they're under separate square roots, I can also squish them back together under the same square root, and I can think about them at the same time. So it might save you a step in a question if you do that. Letter C will be similar to that problem, but let's do letter B first. On letter B, there's also a little bit of simplifying that you can do from the start, but it's different than it was on letter A. 8 and 4 can both simplify, so they can both divide by 4. So this will turn into a 2 and this will turn into a 1. But then notice that you still have the square root of 5, and notice that it's still in the bottom. And there's no way to get rid of that unless you rationalize the denominator. So I'm going to multiply this by the square root of 5 over the square root of 5. I always multiply it by whatever was the square root that was in the bottom, and then 2 times the square root of 5 is going to give me 2 square root 5. The square root of 5 times the square root of 5 will give me the square root of 25, which will come out from its square root as a 5. And so my finished answer will be this. I know that it's finished because there's no square root in the denominator. Also, please notice that there's a 5 here underneath the square root, and there's a 5 here on the bottom that's not underneath any square root. So this 5 and this 5 cannot cancel with each other because this one's underneath and this one's not. If this number was a different number, like let's say 20, I could simplify these numbers, but it's not, so I can't. If you didn't start by fixing the 8 and the 4 here, you would have bigger numbers here and here, and you would have to do the simplification at the end. So some students find it helpful to simplify first, just like we simplified this one first, because sometimes that'll save steps on the problem. But just like all the time in math, I want to make sure you understand that you could do these problems differently and still get the same answer to the question. All right, last but not least, on letter C, I think that this problem would also be easiest to solve if you took the 50 and the 10 and kind of squished them back together. So you're going to have 8 over 24, which will simplify just in 1 second. And then underneath the big square root, you're going to have 50 divided by 10. And so there's 2 things that can change on this one. So when I divide 8 and 24, 8 goes into 8 once, 8 goes into 24 3 times. So those can simplify. And then when I simplify 50 divided by 10, I'm going to get the square root of 5. So the square root of 5 is going to be on the top of the fraction, and then the 3 is going to be on the bottom of the fraction. So even though originally it looked like there was going to be a square root in my answer in the denominator, so I was going to have to do the rationalization step, sometimes I can fix the problem first and avoid having to rationalize it. But if I got to this step and if there was still a square root in the bottom, then I would have to continue by rationalizing the denominator, by picking that number that I want to multiply the top and the bottom both by to find my answer to the question. So in summary, for everything that we did today, you must always rationalize the denominator. If your expression has a square root in the denominator. And you know that it's true that you don't always have to rationalize the denominator if you have a square root in the denominator, because sometimes you can work around it. So this summary is talking about once you simplify, like on letter B right here, we simplified a little bit, we still had a square root in the denominator, and so that's when we had to do the yellow step. Rationalize the denominator is your yellow step from up above. So we would always have to rationalize the denominator if the expression had a square root in the denominator, since you can't have any square roots in the denominator when you're simplifying radical expressions.